everybody, and welcome to your Build Meets World out on the road edition. So I am definitely out on the road. I'm at a brewery in Iowa. We're getting ready to do an event here featuring a lot of the Tremco CPG solutions. It's called Air, Water, Fire, a Building Science Medley. If that's interesting to you, let me know, and maybe we'll come to a city near you with this event. But it's a great way to earn continuing education credit and do a lot of hands-on with the systems as well. So have a pretty cool topic for you guys today that I'm going to focus on. It's pretty basic, maybe not as interesting, people might think, as some of the other topics we've had, but today specifically we're going to talk about sealants. Sealants have a huge role to play on our projects, and I've discovered that there's a lot of maybe misconceptions with them on what's going to work best. So we thought that that's what we'd focus on today. And I also have a special treat because I just gave this presentation on Tuesday at the summer camp, a building science symposium up in Westford, Massachusetts. So we've got some cool little guest spotlights that'll be throughout our presentation today. As always, let me know if you have any questions so that we can address them. If not live, but maybe, later on, I can reach out to you with those specific questions. So bear with me right now as we get the information up and ready to go so that you guys can take a look at the content today. And once again, like I said, we've got a couple guest little features within today's presentation. So I think you'll enjoy that aspect of it. Okay, here we go. And I think I'll turn my camera off just so you guys can kind of focus on the information up there. Okay. So as I mentioned, we are talking about sealants. This was the topic I gave at the summer symposium. And, when you look at the overall scope of what we talk about on a daily basis on Build Meets World and in our blogs, it's about the building envelopes today, whether it's new construction or restoration. There is a challenge, right? And what we end up finding is that majority of what's going on, when we have issues, it's within 3% of that total enclosure. Unfortunately, it tends to be those connection areas, and that's where sealants, play a big role. We also know that this environment that we live in remains to be a multi-billion-dollar expenditure when we have repair and replacement. And everything, once again, comes back to these problems being moisture related, caused by either air leakage or moisture penetration getting into our buildings because of lack of or improper transitioning and detailing. Okay. What we're trying to focus on today is that we want to look at performance, right? Not lack of performance. We want to look at energy efficiency and how we can make sure that these buildings are have a continuous membrane detailed appropriately so we don't have issues. And we also want to make sure that we have a resilient structure so that we're not having issues in the end. And sealants, what is that role that they play? A big role. They are a part of a system, right? They're going to protect the air, protect that building from air and water getting in. And you can see all the other things listed there. They have a big role and they need to be applied appropriately. Now, this is a quick video here that you're going to be looking at that shows a situation where this building did not have good transitions. They did not have good detailing. So we simply covered up all the vents that are allowed for that natural air exchange. And then we turned on the HVAC system. This smoke here was able to get out of the building at that slight pressurization in all the areas where they did not do the appropriate transitioning and detailing. So what we do when we get these sealants ready to go before they even get to that job site to be that winning factor on a project like that from a restoration perspective, or that winning aspect on a new construction, we do a lot to get it ready before it even gets on that shelf, right? So we're going to look at ways that we can evaluate things from a physical property perspective. We're also going to look at ways that we can do different types of exposures, field trials, and then those variances that you all see on a regular basis. So that's basically what we're going to kind of run through today as we look at not only that sealant journey, but more importantly, that sealant selection, right? So as you're looking at your buildings, you're looking at your construction, what's that specification require? Now, and before we even get to that, is the specification correct? What do we need to make sure that our specifications are appropriately, written? So that's something that we can address as well for sure. We also want to look at the application, the substrates, and you can see all these questions as we go on and on and on. This is part of that conversation that we can have with everybody to understand if we're making the appropriate recommendation. So if we just look at the chemistries and the technologies, we've got a lot of options in front of us. Now, this is just a very, very brief information, but this is what we're going to be looking at when we talk at each of the conditions as we move forward. We're going to always be looking at silicones, urethanes, hybrids, acrylics, and butyls. And when I talk about this chemistry and this technology, it's related to sealants only, not an adhesive, not a liquid membrane, not anything else that you might see on a building. So this is truly a sealant that is going to go into some sort of joint, some sort of void where you're going to want a significant amount of movement associated with it, okay? So before we get into that, this is a bit of an eye chart, I know, but if you're interested in learning about how we choose different products and the products related to you from the basis of sealant selection, this is really handy. So you can look at our website and look up sealant selection, and that'd be a great way for you to be able to really check out what we have going on here. But what was interesting is I was at this symposium and I wanted to ask everybody in that room, what do you want to know about when we talk about sealants? So let's take a look at what this person wanted to know as it related to sealant selection.
What about immersion?
Okay, so that's our building science summer camp bartender, and he wants to know about immersion. Now, immersion can mean a lot of different things, right? Are we immersing it in a liquid that's other than water? Is it some sort of chemical? Is it going to be immersed the whole time, or is it just intermittent? So what we really start to look at these technologies is what one of those 5 technologies that I mentioned are going to be great for immersion. So let's kind of take a look at this now. And here you go. Green is going to be good. Yellow is going to be, hey, they could be good, but let's take a look at what makes most sense. And then the red are ones that we're not going to want to have immersed. Okay, now, if you're looking at this chart and you have a lot of questions, and it appears that we already do, this is the kind of question and dialogue I want to have. Now, polyurethanes in general are just going to be a robust material that's going to be able to handle immersed conditions. Now, if it's chlorinated water or something else like that, you're going to want to take a little bit more effort to find out if that's going to be the right product for you. The question I got in was they felt like butyls and acrylics can handle immersion okay. Now, what I'm trying to say here is if it's a membrane, if it's an adhesive or a different type of application, that could be true. But typically, if we're looking at just a sealant, so this is a sealant that's going to go in a joint and have to move and perform with that building movement, that's where I'm going to say acrylics and butyls aren't going to be something that you're going to reach for, right? So silicones, polyurethanes, hybrids are something you're going to reach for, but the yellow marks that you're going to want to take a little bit more some time in terms to making sure that you have the right product. Next up, let's see what this summer camp attendee wanted to know about.
What about temperature?
So he wanted to know about temperature, as he should, right? Temperature is going to be a critical factor when we're installing products. And it's not just the installation temperature. It's the surface temperature. It's the air temperature. We want to know what kind of temperature we're looking at. And we also might have different recommendations for in-use temperature considerations, right? So if we go back to that same kind of setup, if we're going to a hot end, let's take a look at what we kind of come up with. So here's your go-tos for hot temperatures. You're going to have your silicones and your acrylics, and the rest of them are all in a yellow cautionary situation. They are great and can be used in hot conditions, but you're going to want to understand that specific chemistry before you move forward. So that's the only reason why that yellow's there. So let's look at cold. If we think of cold temperatures, how well are we going to do? In this case, we're not going to want to use acrylics when it's cold. Silicones are always going to behave the best when it's cold, but once again, the polyurethanes, those hybrids, and those butyls might also be a great option. They're just yellow because you want to make sure you understand it from a product-specific situation. Next up, let's see what this camper wanted to know more about. This is Michael Kramer with RDH.
What about sound transmission?
Okay, so sound transmission. Now, if we look at those same chemistries again, sound transmission can be something that each of those technologies can contribute to, right? So that rule of thumb, if you think about it, if we stop the flow of air, we will have a reduction in sound transmission. Now, what's important to understand that if you're truly looking for a sound transmission rating, then you're going to want to make sure that whatever sealant chemistry you choose has an appropriate sound transmission rating. So it's an STC rating associated with it, because If you are dealing with different types of vibrations and different types of metals, that's where you're probably going to go to like an acoustical sealant that is either a butyl or acrylic based, right? So those are something that you're going to want to look at, but all of those technologies can help from a sound transmission perspective. Let's see what's up next here. Now, this is Betsy Pettit from the Building Science Corporation. You can see she's thinking all about movement as she's dancing her way through summer camp, right? So when we think about movement, we get into that whole idea of the modulus of elasticity. So the basic way to think about this is if you have a really thin rubber band, it's going to stretch really easy. If you have a really thick rubber band, it's going to be challenging. It can get even more complicated than that, but what we're looking at is how easily does that sealant move so that it doesn't disrupt that bond line, so that it doesn't put unnecessary pressure on the bond line. If we look at that from like that generic perspective, the hardness of the sealant is also going to make a difference, right? So depending on how hard that sealant is, it's going to add to the flexing ability of that sealant, which can be great on something like a high movement metal to metal or metal to glass joint. But if we're looking at structural glazing, well, then we're not going to want it to have a softer nature to it, or something that can move too much, because it's got to be able to hold and steady that glass. Or if we're looking at a sidewalk joint, right, we don't want a really soft sealant that won't be able to handle point loads. So lots of different ways we look at that. ASTM C719 is that sealant specific performance test that we take a look at. And that's, once again, just to kind of reiterate, we're not talking about adhesives or membranes or coatings. We're talking about a true sealant that goes into a joint that has a specific configuration to allow it to move and perform throughout the life of that building. We can do different things, and we can look at technologies. We can be pretty innovative. This technology here is called knotty tear. So what knotty tear means is that if a hole is propagated within it, it won't zipper and cause a much larger failure. It stays isolated to the part where it was cut. That is something that's so interesting. It's such a cool technology innovation. It's in our Spectrum 1 silicone sealant, and it's also in our Spectrum Simple Seal gasket. So it's a really cool technology that really allows you to have maybe even more confidence in performance, because it's not going to zipper when compromised. It's going to be able to be very easily repaired in that failured area. So if we look once again at those chemistries and we look at movement, we've got our green, yellow, red, and in this case, we've got a couple greens and 2 reds. Now, once again, this is when we're looking at sealants. Sealants that are going to go into joints and have to move and conform to that movement. Silicones, polyurethanes, and hybrids are all going to have a much better situation than those acrylics and those butyls. They just don't have that plus or minus 25% movement that we're looking at as a minimum, right? A lot of those silicones, those polyurethanes, and those hybrids go way beyond that. So once again, you're going to want to know specifically what you're looking at from a chemistry perspective. Next up, we have here is a colleague of mine that I actually worked with for many, many years, Scott Walker. He actually works for the Henry Company. Let's see what Scott had to say.
What about material supply, Marcy?
Hey, what did I ask you to ask?
What about adhesion?
So he looks all disappointed there. We were having a nice conversation just about that material supply, inventory issues that I'm sure we're all experiencing. We're still experiencing that. So without getting into any great detail about that specifically, that is something that you're going to want to go ahead and start talking to your material supplier about. We've always focused on really communicating as much as we possibly can. So my best advice as it relates to material supply is get with your Tremco representative early on so that you can talk to them about any of those situations you might run into in terms of inventory supply. But if we focus on the question I asked him to ask, which was actually adhesion, there's a lot of different things we look at when we look at adhesion. And those chemistries are also going to be challenged, right? We want to make sure that things adhere and stay adhered throughout the life of the building. We also look at compatibility as something as well. Those go hand in hand. We need to know both whenever we're looking at anything in specific. Adhesion is one of those things. There's a lot of different ways that we can do it. We're specifically talking about sealant adhesion here, but you can see there's a coating adhesion test going on there. There's an air barrier test going on there. And essentially what we're trying to do, and a field adhesion test for sealants in the lower right, we need to be able to test it in a lab, and then we need to be able to field test it as well, so that we can see if that environmental condition of your installation or your surface prep, what is needed, or is priming needed. Those are all the things that we're going to gain from doing adhesion testing. And when we look at that technology platform again, you're going to find that all of these technologies are going to bond really well to lots of common substrates. I could say red to them all as well because you're going to want to verify it, right? So we want to make sure that you're choosing the right technology that is going to give you that right performance. Okay, and then I wanted to say if you're bonding to that sealant, so say that sealant's in place and you're bonding to it, what kind of conditions are we looking at here? And that's where we have polyurethanes and acrylics are easy and great to bond to. The silicones, the hybrids, and the butyls, I'd want to check on that to make sure that you can bond to those surfaces. And then of course, the silicones, the only thing that sticks to a silicone is another silicone, right? So that's that cautionary red versus if it's a silicone, you're still going to want to verify it, but it does have a good bond to another silicone. This is a friend of mine, Gary. He's busy getting his food and he wanted to know something that we just mentioned on the previous slide, but this was something that he wanted to make sure we talked about.
What about compatibility?
So that's Gary with Horizon. He wanted us to talk about compatibility. And it's interesting because two things can be compatible, but they may not adhere. And that's why they go hand in hand. In this case, we had a silicone sealant with an asphaltic membrane over the top. They were compatible, but that asphaltic membrane did not want to adhere to that silicone. We can also look at this picture here. These are 3 polyurethane sealants with 3 different reactions to this test. So we can't group them all up into one area either. You want to make sure you do product specific testing because we don't want this to happen on your projects. We don't want products that are going to leak or stain, or in this case, continuing to cause issue. Now, this is a rubberized asphalt membrane up into that acrylic sealant on the interior space. That needs to be connected, right, from an air sealing perspective, but maybe we're going to use something that's better than an asphaltic membrane in that window opening, like a liquid applied flashing, like Dimonic 100 or Aqua Flash, where it won't cause that type of interior staining on our sealant beads. And then once again, you might have heard about some silicone staining in the past. You know, how does that react with our products? How does that react with our substrates? We do recommend doing different types of tests. We've got lots of information as it relates to this type of information. So if this is something in your wheelhouse and you want to know more about, and I see a couple questions already popping up about it, let's take this offline and let's address this together at some point. And so I'll reach out to you directly when it comes to this kind of thing, because it is very specific to that product and that substrate. We recommend, you know, even though there's been a lot of advancements in technology, we always recommend doing stain testing. This is true for a stain test. It takes about 2 months. A lot of the other tests I mentioned are much quicker than that, but this is a duration of 2 months because we're starting to do different types of compression and the effects of all the environmental conditions like high temperatures and water immersion and whatnot in a compressed state that might cause materials within those sealants to cause staining or hydrophobic blooming of those substrates. And then if it's structural glazing, that's a whole nother thing that we need to look at. We're going to be looking at adhesion and compatibility of your glass, of your metal, of your gaskets, because we need to make sure that we don't have any issues as it relates to that. And furthermore, every 2 things that come together, we need to ask ourselves, are they compatible? And in many cases, it's not just 2, it might be 5, 6, 7 in a small spot. So this is where I say, please, please, please work closely with your manufacturers. Let them help you so that you understand what your limitations are when we're putting these products together. And here we go. When we look at those technologies again, typically those acrylics are going to be the most compatible, right? They're going to be the most compatible, neighbor-friendly sealants that you can use, but they're not going to be able to handle a lot of the other performance needs you have. So that's where we really need to go back and address that performance situation with each and every one of these, because we can't take one polyurethane and assume it's going to act like all the rest of those polyurethanes in that same space. So here, once again, as we're looking at a couple sealant opportunities, this one particularly, we have some criteria. You can see there on the left-hand side. This is where we're going to use the silicone. When we're really looking for that excellent UV resistance, color retention, and high heat and weather compatibility. Same thing here. Anything structural, glazing related is always going to be a silicone. Silicones come in a variety of different moduluses. The low modulus silicones are going to be great because of that high movement capability. They're going to be really great for dissimilar substrates, and they're really great for EIFs or any type of sensitive substrate where you're worried about that bond line causing any issues or damage to that existing substrate. Medium modulus ones, that's when we get up to something that has a little less movement, but still plus or minus 50 is still a great amount of movement, but it gives you that tensile strength you need for some sensitive applications like when you're looking at glazing. That glass glass to metal application. And then if we're looking here, we're looking at a variety of different applications. The point here is it needs to be paintable, needs to be non-staining because they don't want to test for it. That's where we're typically going to polyurethanes. So that is just kind of where we kind of have as a rule of thumb. If these are the criteria that you're looking for, a polyurethane is going to be the one to grab. And then so on. Here's a variety of other applications that we're looking at. They could be a silicone, a polyurethane, or a hybrid. Same thing here. A silicone, a polyurethane, or a hybrid. Lots of options for you. Now here we have specific parking structure use. It's got to be a traffic rated. They're looking at for it to be pourable. It's going to be going on green concrete. That's where we're going to want to stay with the polyurethane. Okay. Lots of questions coming in right now in terms of specifications or job related questions. We definitely will handle those offline. Here is where we're looking at acrylics. This is where we're going to do something that has that less movement. See, it's got a 12.5% movement. And last but not least, a movement about 10% is you're going to be your butyl sealants. So last but not least here, we have Marty Houston from Walsh, and he had something specific that he wanted to know.
For me, it's all about the install, but don't let me catch you using the spray away glass cleaner.
So he must have had a situation where somebody tried to use something while they were tooling that product. So that's what we want to make sure we don't do. We don't want to incorporate something into that install that could cause an issue with that product. And he's absolutely right. We went through all the different things you got to think about from a selection process, but installation can be even more interesting because we need to make sure we have that right sealant width to depth ratio and so much more. So here's a quick case study for you. In this case, we were using a polyurethane sealant. We installed it in the early fall. It was about anywhere between 45 to 60 degrees outside and sunny. They had so many different applications that they were working on, and we evaluated about 153 different areas. And in this case, here's the rundown of what we found with the samples that we removed, okay? 63 did not have the proper placement of the backer rod. 32 had debris on the bond line. 27 had some issues with width to depth. And 16 had width to depth that was too deep, right? So it can be too thin and it also can be too thick. 8 had a lack of tooling, so they didn't even try to tool that product at all. And then last but not least, 7 of them, they didn't even use the right chemistry. It wasn't even one of our products. So all of these factors come into play when we're installing these products. So not only do you got to make sure you're choosing the right one, just as Marty said from Walsh, we got to make sure we're installing them appropriately. And that takes us back to really understanding our width to depth ratio. That makes sure that we're using the right backer rod so that we're not causing issues with the backer rod. There's always questions about backer rod, so definitely work with us to have that. But what we're looking at is this really nice configuration. We've got a good sealant bond line area. We got good adhesion to our substrate, and we got a nice compatible backer rod in place. Why do we need all those things? Because watch, it's going to move in extension. It's going to move in compression. It's going to move in many, many, many different ways in addition to that. So we want to make sure that it can move. 3-sided adhesion is what is stopped by using a backer rod. So this is a good example here. In this case, it's a metal joinery, and we did not use a bond breaker. So when that moved in those 3 ways, that 3-sided adhesion, it ended up splitting down the middle during extension. We don't want that to happen on our joints. We want that sealant to bond to both of those bond lines on either side and not the underneath, so it can move freely. Here we can see that. We're going to put some bond breaker down. We're going to put that sealant in place, and then we're going to move it in compression and extension, and we will not have adhesion on the bottom, so we'll be able to move freely. That's how we make sure that no matter what type of insulation we have, we want to avoid 3-sided adhesion. The width to depth ratio is something else. As I mentioned on that project, we had some that were too deep and some that were too thin. So width to depth is going to be really critical. And it's always on a 2-to-1 ratio unless you go beyond a 1/2 inch. So the maximum you will ever be on your depth is a 1/2 inch. Even if you have a 3-inch wide joint, you're only going to be a 1/2 inch deep. Now, if you're going anything greater than 1 inch, that is when we're going to want to have a conversation. So we want to be able to talk to you if you're ever going beyond 1 inch. But that depth will never exceed a 1/2 inch. Okay, so that kind of just goes back to that critical capability of making sure that we have the appropriate width to depth. In this case, it was too deep and it caused issues. So we don't want it to be too deep. That's the backer rod, and the backer rod placement is so critical. Here's just a chart here that once again just kind of goes through that. We want to make sure that we're dealing with a width to depth ratio. And that is true even if we're doing a fillet bead, right? Some sort of a perimeter joint. We want that backer out in there so we don't have three-sided adhesion, or some sort of bond breaker so that we bond to either sides, even in an angle bead like this, and we get the appropriate amount of surface contact of our sealant. There's a lot of great ways that we can help you out throughout that sealant installation. We recommend you tracking your weather. That includes your air temperature and your surface temperature. We want to make sure that we are looking at those joints that are sealed that day. So you're marking up and knowing exactly what was sealed at what day and in what condition. You know, who were the crews that you used that day? Because that could be pretty critical as well to understand. Always write down your batch numbers of your sealant and your primer. Keep those in your notes so that you know, so we can get back to you if you have any type of issue. And always making sure that we're looking at that quality install and performance throughout that process. Here's some other pointers we wanted to highlight to confirm that appropriate tooling, because that's going to be critical. As Marty mentioned, you know, if you're going to use something that is not appropriate for tooling, it can cause issues with your installation, which would not be good. So just to kind of recap here, once again, we're looking at so many different substrates, so many different conditions, so many different types of connections. So you're going to want to make sure that you're choosing the appropriate sealant for all these different types of installations. If it's going to have ponding water, if it's going to be immersed, or if it's going to be exposed to different types of chemicals, like maybe at an airport or a manufacturing facility, we're going to want to know what is going to be coming in contact with it. It's going to help us with that appropriate selection. And to add to the complication is it could be a variety of different things coming together, as it is in this picture. EIFS, brick, metal frame, and stone all coming together in one spot. That's where we're going to want to use something that's going to not put stress on the bond line, somewhat of a universal product. We like to recommend a low modulus product. It's something that's perfect there would be a low modulus silicone sealant like Spectrum 1. It's going to bond great to all those different materials, and it's not going to put the stress on the bond line, and it's going to give you amazing movement capability. Just to kind of reiterate here, there's going to be a lot of reasons why people choose different products, different colors. Here we've got a good color matching of not only the grout, but also of the stone. In the other application, what we'd recommend in that one is to match the brick on the right-hand side, because otherwise you're just highlighting that joint. You would see it just as easily visible as you see the mortar. So a lot of times you might want to match the brick instead of matching the mortar. And also, if you don't tool it at all, see those bumps in that right-hand side? That's the indication that we will be able to see that it wasn't tooled. If we don't tool it correctly, it's not going to get into that bonding to those adjacent substrates as easily as it needs to, or excuse me, as well as it should, to get into the nooks and crannies to really perform and adhere as best as possible. Lots of different ways that we can seal, also different types of metal joinery. In this case, now we're looking at a pre-cured solution that's going to go over that metal. The picture in the center there is a sealant that just wasn't able to bridge that metal. In this application, you're not going to get that width to depth ratio. You're not going to get that good bond line. In this case, a pre-cured silicone solution is going to be best. And once again, there is lots of options for preformed options. We've got a lot of things that can be used. Lots of different options we can talk through based on your projects that include silicone, polyurethane extrusions, and of course, pre-compressed foam tapes. So to round this all up here and round off our call today, we want to know what's involved with your substrates when we're looking at sealant selection. We can advise and work together on priming. We can validate adhesion, but we're going to want to understand, you know, what is the condition that's being installed in? Do we have concerns about staining, and do we need to test for it, and so on? We're going to want to understand what level of expansion and contraction are needed so that we can give you the right movement sealant as well as the right shore hardness and modulus. You know, if there's a cure time needed, there is some really cool, innovative one-part single component products that we can catalyze, therefore making a multi-component and really help set up that cure as quickly as possible. Life expectancy is always something that we want to talk to you about, as well as maintenance. You know, coloring is something we want to consider when we're going through these too. If you want a special color, that's always something that is available. And then of course, last on the list is cost. We should start with everything else before we start looking at price. But that's really the gist of what we have today. I see that there's a lot of different questions that we need to answer, so I'll be following up with all of you on that. But if you're interested, as always, if you want to be a part of us on the road, if you're interested in having an event at your location like we are having here today, definitely reach out to me so that we can schedule that. And we already might be scheduled to be coming into your area sometime soon. So thanks again for joining me, and keep those questions coming in.
Thanks for watching. What did you think of that episode? Leave a comment down below with your thoughts, and don't forget to give us a like. Are you interested in seeing more content like this? Hit the subscribe button to stay up to date with all our videos, and we'll see you next time.